Welcome to section 2.2 polynomial functions, day 2. One of the big things we're going to work on tonight is applying the leading coefficient test. We're also going to talk about something called multiplicity and what that does to the graph. Alright, let's go ahead and get started. First off, the leading coefficient test is something that will give you an idea as to what the function is going to look like without ever having to graph it or anything else. Couple things. When the degree is even, alright, remember what we're talking about when we're talking about the degree, that's the highest exponent of the polynomial function. So when it's even and your LC, which is your leading coefficient, is positive, think of your most common even function. Alright, that would be your x squared. Alright, when you have an x squared and your leading coefficient up front is positive, what does the graph look like? Well, we know it's going to open up. Alright, now if this was an x to the fourth or something like that, it's still going to open up. It just might have some extra things going on before it does that. So it's going to begin and end in the same direction, which is going up. Now if the leading coefficient is negative, such as negative 3x squared or x to the fourth or x to the sixth or whatever, then you know it's going to be a reflection and it opens down. And once again, it might be a higher degree, so you might have some extra stuff going on, but it's still going to open down when your degree is even and your leading coefficient's negative. Once again, don't memorize that. Go back to your most common even degree function, which is a quadratic, and take what you know about that and apply it to all even degrees. Same thing with your odd degree. Your most common odd degree is x, which is linear. So if you have a positive odd degree, which is x to the first, let's say 4x, then you know your slope is positive. So it's going to start low and end high. And once again, if it's x to the third, same thing's going to happen. All right. Think about, this is a line, and just, it starts here and ends here. So that's a positive slope. So same thing is going to happen with any odd degree. And if the degree is odd, but your leading coefficient is negative, such as, let's say, negative 4x, once again, just a linear to look at that one, and then now your line will be going down. And same is true for any odd function. So you could start high and have all this extra stuff and then end low. Okay? So your leading coefficient test is talking about the leading coefficient of your polynomial, and then the degree is the highest exponent of that polynomial. So knowing those things, you kind of create this little table here of the different possibilities that you can identify about the graph just based on the degree and the leading coefficient. To lead into that, we have something called end behavior. That's how the graph really kind of begins and ends. As x goes to negative infinity and as x goes to infinity, what is happening to your f of x, which is your y value, for both of them? All right, and so that's the question that we're going to answer is, if this occurs, then what does the function go to? Alright, is it going to go to infinity or is it going to go to negative infinity? So we're going to look at a couple of graphs before we get into all that, just to kind of practice what the degree and the leading coefficient is. So if you look at these three examples, you can pause me maybe for a minute and go through and see if you can identify, is the degree even or odd, or is the leading coefficient positive or negative? You don't have to tell me exactly what it is because you're not going to be able to, but you can identify whether the degree is even or odd or the leading coefficient is positive or negative just based on looking at the graph. So once again, you can pause me for a second and go through and answer those questions and see if you can do so. On the first one, because the graph starts and ends in opposite directions, we know the degree must be odd. Because it starts low and ends high, once again, think about the slope. It starts here and ends here. So that's a positive slope, so that means your leading coefficient is positive. On the next one, the degree, they start and end in the same direction, so your degree is even. And your leading coefficient, because it opens up, your leading coefficient must be positive. And then for the last one, the degree is once again odd because you start and end in opposite directions. But on this one, you start high and end low, so that'd be a negative slope or a negative leading coefficient. And so that's how you can identify, just by looking at the graph, what it is that you know about the polynomial function. And it works both ways. All right, if you know what the function is, what's the end behavior, what does it look like? So the first example here that we're going to do is we're going to use the leading coefficient test to determine the end behavior of the following functions. So what we have up here is what we want to answer. We want to say, all right, if x approaches negative infinity, what does f of x approach? And we're going to answer that question. And also, as x approaches infinity, what does f of x approach? And that's the question we're going to answer also. So we need to know what the graph looks like. So go through, identify the degree and the leading coefficient. And so the degree is the highest exponent, which is 3. So it's an odd degree. And then the leading coefficient is a negative 3. So just to kind of write that down so we have it, we have that the degree is odd and the leading coefficient is negative. So knowing those two things, what does the graph look like? Well, if it's odd and it's negative, it's going to start and end in opposite directions, and since the leading coefficient is negative, it's going to be going down. So something like this. And so now that you know what the graph looks like, you're asking yourself the question, as x goes to negative infinity, which is this one right here, as x goes to negative infinity, where is the y value? So as x goes to negative infinity, what is happening to the y? Well, you can see right here, as x goes to negative infinity, the y value is going to infinity. And then as x goes to infinity, so now we're going to the other side, so as x goes to infinity, what is happening to the y value? Well, it is going down, so it goes to negative infinity. And that's what the end behavior is. So once again, if you want to pause me and do B and C on your own and then check to see if you got them correct, you can do so. So we're going to set it up the same way for B. As x goes to negative infinity, f of x goes to what? And as x goes to positive infinity, f of x goes to what? So degree is 4, which is even, and then your leading coefficient is 5. So once again, degree is even, and leading coefficient is positive. So think back to your most basic even function, which is a quadratic. If it's even and it's positive, it's going to open up. Now once again, there might be some extra stuff in there, but it doesn't matter in terms of the end behavior. As x goes to negative infinity, and as x goes to infinity, where are your y values going? They're both going up. So on both of these, f of x is going to infinity. All right? And because these are polynomial functions and they're smooth curves, and there's no breaks in the graph, there's two options. Either it's going to infinity or it's going to negative infinity. That's it. All right? And then on the last one here, if you were paying attention, it wasn't in standard form. So if you just looked at the 4 and said, okay, it's positive, well, the leading coefficient has to be the coefficient of the highest degree. So you'd have to switch these around, and now your degree is even and your leading coefficient is negative. So this will be something that opens down because of the even degree and the leading coefficient being negative. So let's see here. We got x. As x approaches negative infinity, what does f of x approach? And as x approaches infinity, what does f of x approach? And so as x goes in both directions, your y value is going down for both of them. So both of these would be negative infinity. Okay, so that's, these two things go hand in hand in terms of the leading coefficient test, understanding the degree and the leading coefficient, which then leads into the idea of end behavior. How does the graph end? As x goes to negative infinity and as x goes to infinity, where is the y value going? Is it going to infinity or is it going to negative infinity? And so you can answer all those questions based on just looking at the polynomial function. You don't need a graphing calculator to identify any of this stuff. Okay, so that's kind of the first part of the notes. The second part of the notes, we're going to get into this idea of something called multiplicity. And so before we do that though, let's just refresh that zeros of a function. Those are your x-intercepts of the graph. And I have two, one being a quadratic and another one being x to the fifth, but I have two polynomial functions here that we're going to solve pretty quickly just to show you what the solutions are. So kind of go through that process again. We're going to solve by factoring. And so you have x minus 3 times x minus 3. Set your factors equal to 0. And so what you notice on this one, you get x equals 3 twice. But when you go to write your answer, you only write it once. But we're going to get back to this idea that when something occurs more than once, what actually happens on the graph. So keep that in mind as we kind of do the second one here. Set your other one equal to 0, factor out the GCF. And if you remember, we actually did this one yesterday in the notes. And I talked a little bit about this as to what happens when you go to solve. So we get negative 2. I'm going to write it out the same way I did the other day. Negative 2 times x times x times x. And then you can do difference of squares. And so you see you have 5 total factors. I don't know if I can highlight these. 1, 2, 3, 4, and 5. They have the variable of x in it. And so when you go to solve, you have negative 2x to the third is equal to 0. Well, I'll do it this way. I'll do it all 3 ways. X is equal to 0, x is equal to 0, x is equal to 0, x minus 1 is equal to 0, and x plus 1 is equal to 0. So those are your 5 factors. You get x equals 1 and x equals negative 1. And so once again, when you go to write your solution, even though this x equals 0 occurs 3 times, you're only going to write it once. So x is equal to negative 1, 0, and 1. So even though we have a degree of 5, when we go to write our answers, we only write 3 of them, and that's because x equals 0 occurs 3 times. And this is where the multiplicity comes in. And so this idea of repeated zeros for a polynomial function, a factor right here that occurs this number of times, which is your exponent, all right, yields a repeated 0. And so what we talk about is we talk about multiplicity. So this factor, x minus a, yields an answer, of x equals a, but it happens multiple times. So like on the example up here where x equals 0 happens 3 times, the multiplicity is 3 because it occurs 3 times. So what we want to look at is we actually want to look at the graphs of each of these. So there's 2 possibilities. The first one, all right, if k is odd, so back up here just to show you, on this one, for x equals 0, k was equal to 3. It happened 3 times. This one over here, for x equals 3, k was equal to 2. It happened 2 times. And so if k is odd, the graph crosses the x-axis at x equals a. Now it crosses, but it doesn't just cross. There's like this bend that occurs. So I'm going to say cross, but I'm also going to kind of add to that right there that it bends. Okay, because it doesn't just cross straight through, it kind of bends as it goes through. With an even one though, and once again think of your quadratic, with an even one, the graph touches the x-axis. It actually doesn't go through the x-axis, so it just goes down, touches it, and goes back up or goes back down. And so when you're solving these polynomial functions and you see a multiplicity and you see something occur more than once, then now you have an idea of what's going to happen at the graph. And this is going to become important later when we start solving these things besides just by factoring, and we're going to look at the graph and identify some things from it. And so knowing what happens when you go to graph these and see that bend occur, knowing that it happens at least 3 times, is going to help you solve polynomials of higher degree. Okay, so this isn't just a one-time thing. We're going to come back to this and really talk about what happens when we go to solve some harder and more complex type of problems. All right. So once again, multiplicity is how many times a factor occurs. If it occurs an even number of times, then it's going to touch the x-axis. If it occurs an odd number of times, then it crosses the x-axis, but it has a bend at the x-axis. And we'll look at that on the graphing calculator in class so you can kind of see what I'm talking about. So to talk about this idea of relative extrema, which we talked about the other day, and this is just to kind of give you some idea as to what's also happening. The relative maxima and relative minima is located between the x-intercepts. So I'm just going to graph a generic function real quick here. Alright, and so when you go to do this, they in between the x-intercepts, you're going to see these relative max and mins again that we talked about the other day. Okay, and so in between the x-intercepts, here and here, there's going to be this relative max. And once again, we're not going to find these right now. This is just giving you information about where they occur and things like that. So in between 2 x-intercepts, you're always going to have a relative max or min because it's going to have to cross back over. So it's always going to, somehow occur where there's going to be a max or min value in between that. So once again, we'll talk more about that kind of as we go forward here, but just keep that in mind as we're talking about polynomial functions. So what I'm going to have you do on this last one, and once again, you can kind of pause me and go ahead and try it yourself and then check to see if you did it correctly. We're going to find all the following about the function. We want to find the degree, the leading coefficient, the end behavior, and then the zeros of the graph. Remember, the zeros are the x-intercepts or the roots. So here we go. And once again, you can pause if you want to try it on your own first. So the degree is and this is in standard form, is the highest exponent of the polynomial function. So the degree, what we're really looking at is the degree is even. But if we want to get specific on this, it's 4. Okay. The leading coefficient is the number in front, which will be 1, but what we're focused on is that it is positive. And then the end behavior. Well, now that we know what this is, we know the graph will open up. So the end behavior as x goes to negative infinity and as x goes to infinity, what is happening to your y values? Well, they're both going to infinity. So you say as x approaches negative infinity, f of x approaches infinity. That's what you're answering. And as x approaches infinity, f of x approaches infinity as well. So they're both going to infinity. And then the last part is to solve the polynomial. And we're going to always solve so far is by factoring. So we're going to continue that trend. set it equal to 0. And so you have x squared. Then you can factor x plus 3 and x plus 1. And so you actually have 4 factors. You have x times x plus 3 times x plus 1 is equal to 0. And so all 4 factors you set equal to 0. X equals 0, x equals 0, x plus 3 equals 0, x plus 1 equals 0, and solve. And so you get 4 solutions. One of them has a multiplicity right here, has a multiplicity of 2. Let's fix that. Oops. And so your solutions are x equals -3, x equals -1, and 0. Okay, you only write the 0 once when you're doing that. And so those are your solutions, or your zeros of the graph. Alright, so if I can real quick, I'm going to try to do something here. I'm going to try to use the graphing calculator. I'm kind of new at this part of it, so hopefully everything works out. But I want to graph this one and kind of show you, since it does have an even multiplicity, that we should see it touch the graph as we go through. And so I'm going to make sure that I have the right one. X to the 4th plus 4x cubed plus 4x cubed plus 3x squared. Alright, so what we're talking about is at 0, you can see how, I don't know if I can write on this or not. Nope. So you can see how right there where I pointed at, I guess it did make a little 0 thing. That one goes straight through. This one goes straight through. But at 0, I'm going to zoom in a little bit. But at 0, see how it just touches and then goes back? It doesn't cross through. And that's how we know that right there, there's an even multiplicity that is occurring. And we already solved this, so we know at x equals 0, it occurred twice. So that's what you can expect to see on the calculator. And you can also plug one in and see what happens with an x cubed as to where it bends. So let's see if we can do that real quick. Let's go back to y equals, and let's just do generic 1x cubed. So this would give us 3. So once again, look what happens right here. See how it bends? It crosses, but it also bends right there at the 0. Alright, and so that's what you can expect to see when you have an odd multiplicity. Alright, so that is the end of 2.2 day 2 with polynomial functions, and talking about end behavior and leading coefficient test, and also really getting into this idea of multiplicity, which is going to be a big thing in terms of solving higher degree polynomials and things like that. So we'll continue to work on that as well as we build through all this polynomial function stuff.